In this video, we're going to have a look at adding and subtracting fractions using the method of least common denominator, and then also looking at fractions visually so we can really understand them. That's today on High Peak Education. What's going on, everybody? I hope you're having just a great day. Thank you for the support of this channel. Thank you for watching these videos. Thank you for supporting us. And I hope that these videos are a value add to your life, that they add to your life, your education, your understanding, and otherwise. So for today's video, we're going to look at several examples of adding and subtracting fractions together. And then also we'll look at visually or geometrically how we can understand fractions by keeping the numerator the same but changing the denominator, or keeping the denominator the same but changing the numerator. And we'll see how fractions are displayed visually today. So let's get into today's content. The only difference, the multiples are the denominators, right? Otherwise, you use the concept of least common multiple. And remember, it's just a quick reminder, but I feel like it bears repeating. When you have a greatest common factor, remember with the greatest common factor, you have to take only what's shared between two things. So like for instance, remember with 120 and 12, we had to take 2, 2, and 3, because that makes 12. But like say for instance with 40 and 9, 40 and 9 didn't share any factors. So, we didn't have a greatest common factor. Remember with least common multiple, you have to take all of the uniqueness. In other words, you need to take one of each of the prime factors. So remember, with 3 and 6, we had to take both 3 and 2, because that makes up what 6 is, but 3 is just by itself. But then remember, when we had 3 and 4 from last time, we had to take all of 3, and we had to take 2 times 2, which is 4. So we had to find that 12 was the least common multiple. So what I'm trying to get at is that if greatest common factor is what you take to take what's shared, least common multiple is you take all of the uniqueness. See the difference?
Yes.
Greatest common factor would be like overlap. Least common multiple would be like make sure you include everything.
Okay.
See the difference by contrast?
Yeah.
One of the things we did is we proved visually add, say, 2/3 together with 1/6, and you should get 5/6.
Okay.
Remember we saw this last time?
Yeah.
And then we also proved that you could take 3/4 plus 1/3, and if you cut things up into 12ths, remember we talked about this? You should get, when you add them together, 13/12, which is more than a little more than one full pie. Okay? Okay, so let's try another one. Not quite as easy as 3 and 6, but not so different where 4 and 3 we have to take entirely different numbers and just multiply them. So what do we have? 3/10 plus 1/15. Now let's start walking through this. So first of all, we want the what of these two denominators, since they're not the same?
The least common denominator?
Yeah, so we want the least common denominator of 10 and 15, right?
Yeah.
And remember, that's basically more or less the exact same thing as the
Least common multiple.
least common multiple of 10 and 15. Okay, now let's do the little trees. Remember, these are called factor trees for 10 and 15, shall we? Okay, so let's get started. 10 starts to break down into what times what?
5 and 2.
5 and 2, I agree. Are we done, or are those prime numbers?
Those are prime numbers.
I think so, because 5 can't be divided in half or by 3 or anything, and 2 is definitely prime. Okay, so we're done. How about 15?
5 and 3.
5 and 3. Okay, so remember, we need... Oh, and by the way, is this one done, or those can break down any further?
I think it's done.
Yeah, it's done. 5's prime, 3 is prime, we're done. Now remember, if we wanted, this is just a quick side note, if we wanted the greatest common factor of 10 and 15, what number would that be? That's not what we're doing here, but just a reminder. What's the greatest common factor of 10? So what number do they share?
5.
5. See how 5 is repeated?
Yeah.
So the greatest common factor would be 5. Okay? In other words, if you had 10 15ths, you could divide the top and the bottom by 5. Yes? And you would get 2 over what? 2 over 3. And you see that 2, which is right here, that's also right there. And you see that 3, which is the denominator, whoops, let me do it this way, is also right there.
Okay.
Right? I mean, it's the other part of the tree, basically. You can see, you know, if the tree breaks down into 15 as 5 times 3, then you get rid of the 5, the only other root is the 3, right?
Okay. Yeah.
Okay, now with all that in mind, we now want to move on to least common multiple. So least common multiple, do we need 1 5 or 2 5s since 5 is shared?
2.
Not 2 5s because we only need the uniqueness. Is 5 unique to both of these numbers?
No.
No, so since it's shared, we need the 5, but we only need 1 5. See that so far?
Yes.
We only need one of these, 1 5, for the least common multiple. Do we need the 2?
Yes.
Because it's unique to the 10. Do we need the 3? Yes, because it's unique to the what?
15.
The 15. Okay. So the next question is, what is 5 times 2 times 3? So first question is, let's make it simple on ourselves. What's 2 times 3? Yeah, so we got 5 times 6, which is what number?
30.
30, good. And let's also review from last time. Let's make sure there's another way we can check this. This is a least common multiple. If you start listing out a times table for 10 and a times table for 15, 30 should be the first number that what?
That is shared?
Yeah, exactly, that they're both shared. So let's start the times table for 10. So it'd be 10, what's next?
20.
Yep. And then what would be next?
40.
Okay, and then we just keep going, right?
Yeah.
How about the times table for 15? We should start with 15. Then what's next?
30.
30, and then 45, and then so on. Have we reached our first least common multiple?
Yes.
I think so. It's right here. Do a little more cleverly, and you could do this, right? Like that, right? And you can see that 30 is right there, right? Kind of line it up. But however it makes sense to you, right? 30 is indeed the least common multiple. And because remember, it's the first number they both multiply up to, and it comes from all the shared numbers. By the way, this may not be the exact way you were taught to do least common denominator, but this is, how do I say this? This is the more tried and true way, and it always works if you understand the process.
Okay.
Like you'll never get it incorrect if you understand the process. Okay, so if 30 is the least common multiple, I want to ask you, what should 10 be multiplied by in order to get to 30? Yeah, 3, I agree with that. And then what should 15 be multiplied by in order to get to 30?
2.
Yeah, 2. Now here's a quick question, but this is a reminder, and this is something you should know by now. Why are we multiplying both the numerator and the denominator for the first fraction? Right, it has to be fair. Okay, so since math is fair, 3 over 3 is another form of what's very special number. 1, right? 3/3 is 1 whole. Whenever you multiply anything by 1, do you change the value? But you do change the form, right? We talked about this last time. You change the value, but not the form, okay? By the way, I keep mentioning these certain themes because they're so important. With multiply by 3 over 3 for 3/10, with multiply by 2 over 2 for the 1/15. By the way, do you also see that you could also look at this in terms of the trees? Do you see that 15 is missing the 2, and then 10 is missing the 3? You agree with that?
Yeah.
From this little trio, 5, 2, and 3, right?
Mhm.
Makes sense, right? So that's another
Yeah.
way to think about this. So if you wanted to, you could say make this one in blue, right? 3 over 3. Just to
Mhm.
remind yourself, hey, 10's missing the 3. And then this one is 2 over 2, right? Hey, 15's missing the 2. I mean, again, the color just helps it make it a little more concrete. Let's change this first fraction. So we got to multiply 3 times 3 in the numerator. What do we get?
9.
Yes, so we get 9. And then we got 10 times 3 in the denominator, which we get what?
30.
30. I agree. Let's do plus. And then we need, what is 1 times 2 for the numerator?
2.
2. And then 15 times 2?
30.
30. And it better be the same denominator, right? It has to be 30.
Yeah.
Otherwise, we did something wrong. So then what do we do when we do 9 plus 2? 11 over 30. And that should work. How's that feel to you? Good. By the way, tenths and 15ths are very, very small slivers of fractions. So in order for me to do like the circles with the pieces, like that would take a long time. Plus, I mean, I think that you've seen 2 examples of that. So hopefully you're convinced visually that it still does work, right?
Yeah.
You're just making more cuts.
Mhm.
That's all you're doing. You're making more cuts by getting a least common denominator. Okay?
Okay.
All right, great. I would like for you to add 3/8 to 5/12, please. Okay. So you tell me, what should the first step be? Right, least common denominator.
Or similar to it.
Yeah. Of what two numbers?
8 and 12.
8 and 12. Okay. How should we proceed? Yep, let's do the trees. By the way, the trees are always a good place to start because you can always take any number, break it down into its factors, and it helps you to understand the number. Okay?
Alright.
Okay, so it's never a bad thing in my opinion.
So, and then 12 would be 3 and 4.
3 and 4. They do. Now 4 would break down into 2 times 2, but here's the deal. Does it make sense to you that you could either say 4 is shared or both 2 and 2 are shared?
Yeah.
So basically, here's the deal. If they share an earlier branch, they share the full root. You agree?
Yeah.
Because they basically share this whole thing, right?
Okay.
They
so
share
you
this,
don't
this
need
whole
to-
Yeah, so you don't really need to sort of finish it if you don't want to. But,
Okay.
I mean, you can. You don't have to.
Okay.
But, so they do share a 4, I agree. But what do they have that's different? 2 and the 3. So if we need a least common multiple, we need all the uniqueness. So what 3 numbers should I multiply here? Yeah, I should multiply 3 numbers to get the least common multiple. So first off, let's do the shared number. What's the shared number that they both have? 4. What's unique about 8 additionally? The 2, yes. What is unique about 12 additionally?
3.
Yes, the 3. Does that make sense?
Yes.
You have to understand, you need all the uniqueness, right?
Okay.
All the diversity, if you will, okay? I don't know, I don't always use the word diversity these days because it has such political ramifications. I mean, I'm all for equal opportunity, but, you know, I don't know. Diversity kind of has all the uniqueness. But anyway, what was I getting at? And by the way, 4 times 2 times 3, you can do that in any order, right?
Okay,
So I suggest start with the smallest numbers. Let's start with 2 times 3. Gives you what? Yep, so we need 4 times 6, which is what?
24.
24. Notice you could have done 4 times 2 to get 8. 8 times 3 is also 24.
Mhm.
Or you could have done 4 times 3 is 12, and then 12 times 2 is 24, same thing. Okay?
Okay.
All right, so you're saying the least common multiple is 24. That's the least common denominator. So what do we need to take 3 over 8 and multiply it by to change it with the 24? 3 over 3. And the thing is 8, it's basically more or less, he's saying, I'd like to have this 3, right?
Yeah.
Okay? So, oh, whoops, I'm sorry. And then I wrote 3 over 2. That was totally my bad. 3 over plus, and what should the 5 over 12 be multiplied by? 2 over 2. Yes, and that's because 12 is saying, hey, I have a bunch of 2s, but I'd like to have one more, right? It's over there. Okay. I mean, you could personify these things, give them their own voices if it helps you make sure you get it, okay?
Yeah.
There's nothing wrong with that. Okay, what do we get when we multiply the first fraction up?
It's 9 over 24.
9 over 24, excellent, plus 10 over 24. And then we finally can add them.
19 over 24.
19 over 24. Now, by the way, one question I didn't ask on the last question, I should have, and I can ask on this question is, are we done or does it reduce?
We're done.
Because you are correct, and why is that? 19 is what sort of a number? Yeah, it is prime, right? Have you ever seen 19 on the multiplication table? I don't think so. I've seen 18, right? That's 6 times 3. Or, let's see, 9 times 2. I've seen 20. That's 4 times 5. Or 10 times 2. But I don't think I've ever seen 19, right?
Yeah.
Just that's where being very familiar with the multiplication table is also very helpful, right? I don't insist that you memorize the prime numbers, but you should at least be familiar with which ones of the prime numbers up to the 100, okay? So I'd recommend you keep this kind of in your notes somewhere, okay? So these are all numbers you should be familiar with. We've already talked about 2, 3, and 5, and 7 a lot. But notice we've got 11, 13, 19. By the way, are any of these numbers going to be even? No, none of them, because they all be divisible by 2, right? So they all at least have to be odd. So let's see, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 90. Notice that the spacing between the numbers gets a little bit larger in terms of 1 to 100. This is like a way to see them all where they fall, right? Okay. At first, they're kind of close to each other. I mean, 2, 3, and 5 are super close to each other, as is 7. Then 11's a little further, 13's a little further. 17 and 19 are far, but then you see how the spacing gets more and more?
Yeah.
There gets to be more green in between them, so to say.
Yeah.
And that's because generally the bigger the number, the more opportunities it has to have a factor. I mean, there's certain numbers that people sometimes think like are prime and they aren't. One of my favorite examples is number 51. You might say, what in the world goes into 51? Well, 51 is 3 times 17, which is not obvious, right?
Yeah.
3 times 17. Take the number, I don't know, 77. I don't know if that one's somewhat obvious too, but that's 7 times 11. But those are the only factors, right? But it's not prime. That's important. 37 was, 47 was, 67 was, but 57 was not. Now 57, I'm less familiar with what the factors of 57 are. Let's see, 19 times? Yes. 19 times 3 is 57. 8 times 3. Now that's not obvious. I don't know about to you. That's not obvious to me. Okay? But again, I don't insist that you memorize the prime numbers up to 100, but let's put it this way. I think it's a good idea to at least be familiar with them. Okay? To know which ones are prime and which ones are not.
Okay.
Sound good?
Yes.
All right, so prime numbers are definitely a useful thing. Are we ready to move on to subtraction? Okay, so subtraction, the only difference, of course, is you're subtracting. When we do subtraction, do you think the process is going to be like any different, really? 3/8 minus 1/12. So let's start off easy. Let's do 3/8 minus 1/12. By the way, part of the reason I didn't do 3/8 minus 5/12 is because I'm not 100% sure which one's bigger. So that's one of the last things you and I will work on when it comes to fractions. Which fraction is bigger, okay? Well, it turns out we actually do know from here because 5 over 12 was 10 over 24, and 3 over 8 was 9 over 24. So 5 over 12 was just a little bit bigger. So if I'd have done 3 over 8 minus 5 over 12, I would have got a negative number.
Okay.
Now, by the way, let me ask you, how familiar are you so far with negative numbers? Okay, I just don't want to kind of reintroduce that in terms of some of this review stuff until later, but For now, I just wanted to make sure that we get a positive number when we subtract here. Okay, but let me ask you this. Do you think that the least common denominator is going to still come into play here?
Yeah.
Is the least common multiple still the same thing as the least common denominator, except with the denominators?
Yeah.
Sure, definitely. Is it still going to break down into, let's see, that was 2 times 4 times 3, okay? So the least common denominator between 8 and 12 should be 24, right?
Yeah.
By the way, the faster you get with least common multiple, it turns out that you don't necessarily need to do the trees. Like, some people can just say, oh, 8 goes 8, 16, 24, 32, and so on. And then 12 goes 12, 24, 36, and so on. Oh, 24 is the least common multiple, right? So the faster you get with this, the faster you got to do it. Can we still change the denominator as before? Yeah, sure. So we're going to multiply this by, what is that, 3 over, and we're still going to multiply 1 over 12 by what? 2 over 2. Yep, because 12 is 3 times 4. That's sitting right there, so it's missing the 2. So we get 9 over 24 minus 2 over 24, correct? Okay, what would you get when you do that?
You get
7 over 24, okay. Are we finished? Okay, so 7's a prime number, but remember, is the denominator a prime number? No, it's not prime. But here's the deal. If the answer would have been 7 over 21, we would have reduced that to 1 over 3. Because 21 has factors of 3 and 7.
okay.
Because, remember, and we talked about this in the rules before, right? If the numerator is prime, the only way you're not done in terms of simplifying a fraction is if the numerator, the entire numerator, is a factor of the denominator, right?
Okay. Yeah.
So 7 over 21 is not done, but 7 over 24 is.
Okay.
Because 7 is not a factor of 24, correct? Okay, so I have 10/14 minus 5/21. Okay, so you tell me, what should we first seek to perform this subtraction? We do. That's just like the LCM
Yes.
of what two numbers? I agree. Okay, so what should we start off with next? Okay, what does 14 break down into? 7 and 2. We done with those?
Well, yes.
Yes, because remember, like we talked about, right? Good to familiarize yourself with the prime numbers. 7 and 2 are on here, right? They're both prime. 21, 7 and 3. Love it.
So, they by 2 multiplied by 3.
Love it. Nicely done. Okay, I always recommend multiply the smallest numbers first. What's 2 times 3?
That's 6.
Yeah, what's 7 times 6? Testing your multiplication today. 7 times 6 is 40. Good to know the good old times tables. What should we do with 10 over 14?
Multiply it 3.
Yep. Now, if you're not sure, remember 14 is made up of these two, which is these two, so it's missing this. It's missing this, right?
Okay.
That's why I always recommend the trees, because the trees tell you everything. The trees reveal the numbers, right?
Okay.
It's and I mentioned this before, right? It's like taking a person and dividing them up into their skeletal system, their circulatory system, their muscular system, and so on. Once all the parts are kind of laid on the table, the doctor's like, oh, I can fix the problem, right? Okay, so there we go. And then we're going to do minus. And then what should we do with the 5 over 21? Because that one's missing here and there because it's already got 7 and 3. Awesome. What do we get when we multiply the first fraction? 30 over 42, I agree, minus
10.
42. And what do we get when we subtract? 20 over 42. Now 20 over 42, we done yet? I don't think so. Yeah, we're not done. Do they have a greatest common factor? By the way, this is why we talked about greatest common factor before we talked about least common multiple, right? And by the way, if you're not sure, we could always just do the quick trees for 20 and 42, right? There's nothing wrong with that. By the way, 42, we've basically already got its tree. Do you see that 42 is going to break down into 7 times 6? Sorry, I'm running out of room, but 2 times 3, right? Because we already constructed it before. Does that make sense? We already constructed it. There's no reason to like rethink about it, okay?
Yeah.
It's already 7 times 6, which is 7 times 2 times 3. 20 breaks down into what? 10 and 2, yep. And then 10 breaks down into 5 and 2. So what's the number that they share? Yeah, it's only 2, I think. Yeah. Do you see that? It's only 2. Only 2. Okay. All right. So let's divide top and bottom by 2. That's the greatest common factor. And what do we get? 10 over 21. Yep. Okay, so 10 is 5 times 2. We just deduced that. And 21 has to be 7 times 3, because that's the other parts of the 42 there. None of the factors are shared, so yes, we are done.
Okay.
10 21sts. Okay, how's that feeling for you? Or do you feel like we need one more practice subtraction, or do you feel like you kind of got this?
I think I got it.
You think you got it? Okay, I mean, you definitely seem to have it pretty well by now. I mean, so let's pause. How well do you feel about multiplying, dividing, adding, subtracting fractions at this point? Okay, so I mean, obviously we're going to move on from here because we've got plenty of other math to review or build us up to the algebra stuff. But suffice it to say, these skills will come in because very soon we're going to have fractions that have variables in them. So we have to understand greatest common factor, least common multiple, okay? Let's see, there was something else I was going to mention. Yeah, so my suggestion now is let's go back to the beginning list. This was like many days ago. Okay, so one of the things I recommended that we did also do is to compare or identify fractions. Now, we already kind of started talking about that, but I suggest that we take a look at this in a little more detail, okay? And then I suggest we can move on to reviewing decimals a little bit, and then negative numbers, and then I'm going to suggest we can start in on some algebra, get into the meat of it, okay? It's kind of some real algebra. Let's compare some fractions. Okay, so we've kind of seen this before. Let's start off as easy as we can think of. Let's start off with halves, okay? So we've got 1/2, okay? So if I put another wedge in there, how many halves would there be? 2 halves. Pretty straightforward. Now, by the way, the cool thing about PhET here is you can change what the shape looks like, but I want you to predict what the shape looks like. Suppose I have a horizontal rectangle. Where would you expect the cut to be in the horizontal rectangle if it's 2 halves?
Middle?
Yeah, in the middle. Do you see that right there?
Yeah.
So right there in the middle. What if I have a vertical rectangle? The cut should be also down the middle, but that time vertically. Now this one actually cut horizontally, but again, you could also cut it vertically. How about if I had a cylinder of water? Let's say like a cylindrical cup of water. Let's go back to 1/2 for a second. What would you expect the cylindrical cup to look like? Yeah, like that. So the water fills up from the bottom and it's up to the middle, right?
Yeah.
And then notice that here is just the exact same thing as the circle, except this is now 3-dimensional, like a birthday cake. You see that?
Yeah.
And by the way, let me ask you this. How far along the number line would 1/2 be? In the middle of 1 to 0. It's 1 to 0 like that. Okay? Okay, cool. All right, let's now try something a little more detailed. Let's try thirds, and I want to do 2/3. So how many wedges do I need? Well, I want 2/3, so I want how many? 2 out of 3. Okay? How many out of the 3 wedges here in this rectangle? Yeah, so 2 out of 3. Same with this one, 2 out of 3. And then how about this cup? Is this cup going to be more than half or less than half full? More than half. Do you see that? Because it's 2/3. And then same here, 2/3 of a birthday cake. So again, are we going to be closer to the number 1 or are we going to be closer to the number 0 on the number line? Closer to the 1. You see that?
Yes.
Okay, good. let's be a little more thorough and let's try 2/4. So how many wedges do I need here?
2.
2. Now 2/4 is an equivalent fraction to what that we've already talked about? 1/2. So shouldn't these all look like 1/2 except that there are more cuts?
Yeah.
You see that?
Mm-hmm.
We always have 2 out of 4, but we're exactly halfway on each of these. Yes?
Yes.
Okay, awesome. Why don't we try 3/5? Okay, so this is getting a little harder. So 3/5, how many wedges of the pie? Yeah, we just need 3. 1, 2, come on, there we go, 3. Now notice what the shape looks like. The shape kind of looks like a you know, if you've ever seen one of those pentagons, those stars, right? There'd be like a star here, tip there, tip there, tip there.
Mm-hmm.
Okay, so we're still going to have 3 out of 5 on the rectangles. Is the cup going to be more than half full or less than? Just barely more. Now look closely here. 3 out of 5, wouldn't that be the same thing as 6 out of 10? And this is where, just by multiplying 2 over 2. Now this is where I want to touch on your intuition a little bit. 6 out of 10 would be 6/10. Wouldn't that be the same thing as 0.6? 6/10 is the same thing as 3 out of 5 is the same thing as 6 out of 10. Correct?
Yes.
Which is the same thing as 0.6, because we would call this 6/10,
Mm-hmm.
which is the same thing here in decimals as 6/10. Which, by the way, if you wanted that as a percentage, what would that be as a percentage? 6/10. Nicely done, 60%. Because wouldn't that be 60 out of 100? 6/10 is the same thing as 60 out of 100. Remember, percent means per 100. Now, here's the deal. Is 60% more or less than half? A little bit more. So do you see how this cup is a little bit more than half full? And same with the birthday cake. We're going to have a little bit more than half? We are. You got to look at it carefully here. It's a little bit more than half.
Yeah.
And then how about the number line? Are we closer to 1 or 0? We are closer to 1 slightly. Just ever so slightly. See that there? Okay. Starting to understand these fractions?
Yeah.
Okay, good. Let's do one more. And by the way, again, this is not always super easy. And not everybody gets this right perfectly the first time. Okay? So let's try 4/7. 4 wedges. Now look carefully. You think we're greater than a half or less than a half? Yes. Now let's think about why this is. 4, watch this carefully. 4 out of 8 would be a half. You agree with that?
Yes.
But 4 out of 7, think about this. If you have the same number of wedges, say 4 for the numerator, but you have less cuts, each wedge is going to have slightly more value than the 4 out of 8 wedges.
Mm-hmm.
So just watch me toggle between this. This is 4 out of 8. This is 4 out of 7. Do you see that the 4 out of 7 each have slightly more value in each of them, right?
Yeah.
So in other words, if the numerator stays the same, but the denominator is going down, the value of the fraction is going up.
Okay.
Does that make sense? In fact, you could prove this to yourself if I keep decreasing the denominator. I mean, look at that. 4 out of 5 wedges is like even more, right?
Yeah.
So if the denominator goes down, but the numerator stays put, the value of the fraction goes up. Is that clear?
Yes.
4 out of 7 of the rectangles, 4 out of 7 of these rectangles. Should this be a little bit more than halfway?
Yes.
A little bit more than halfway, a little bit more than half the cake left, and a little bit closer to 1. Ever so slightly, but a little bit closer to 1, right? All right, cool. So one of the things you saw in this video is that we can add and subtract fractions together as long as we have a common denominator. But understanding how to get a common denominator is based upon least common multiple, and also we need to know how to multiply by some form of 1. that is the same number numerator and denominator to get a common denominator. And that is required for either adding or subtracting fractions. We're not talking about negative numbers yet, so the number that you're subtracting off must be of smaller value than the number you're subtracting from for now. And then we started talking about how to display fractions visually. So hopefully one of the things you realized is that if you keep the numerator the same, but then increase the denominator, the pieces of the fraction are increasing. That is, there's more wedges, and so each wedge is smaller, thus the overall value of the fraction is less. If the denominator goes down, decreases, and the numerator stays the same, then the value of the fraction is increasing. Now, we didn't discuss this very much today, but if the denominator stays the same and the numerator is increasing, you just have more wedges to the pie, so to say. So the value of the fraction is actually increasing. So hopefully that kind of all makes sense. We'll be looking at more examples of these things coming up. So stay tuned for more videos in the series. And I want to thank you for watching High Peak Education. Please smash that like button if you enjoy this content. Please share the channel amongst your social networks to grow the channel and to gain influence and value for everyone in participation. Social media links are down in the description below. Please let us know in the comments what other videos you want to see, what other things you want to let us know about the content of these videos. We really appreciate hearing from you, and thank you so much. Please support us on Patreon, and otherwise, I will plan on seeing you in the next video.